Hello, this is Charlene. In this video, we're going to be talking about fundamentals of probability, specifically with respect to a fair coin that is tossed two times in succession or in a row. But let's think about probability in a general way before we work out these problems. So, generally speaking, the probability of an event E, such as tossing a fair coin two times, is denoted by P of E and is given by this equation. So the probability of an event, the P of E, is equal to the number of ways an event E can occur divided by the total number of possible outcomes. So again, all this is going to be related in this video to event E. And event E is talking about tossing a coin two times in a row. So more practically speaking, this right here, this equation can be thought of pretty consistently in a probability as part out of total. So the number of ways an event E can occur out of the total number of possibilities. So the part out of the total, or you could think of the part out of the whole. So this is a very general but very pervasive idea in probability. Think of it as the part out of the total or the part out of the whole. All of your probabilities are going to be based on this kind of ratio. Okay, in probability, we always need to know what this total number is first. We call that total number the set of equally likely outcomes. So we're going to have to figure out what are all of our total possible options. So let's think about the fact that we are going to toss this fair coin two times. So we're going to have a first toss and a second toss. So on the first toss, we could get a head, right? And on the second toss, we could also get a head. So that is one option right there. On the first toss, we get a head. And on the second toss, we get another head. So that could be our first option. Okay, so the next possibility could be that we get a head on the first toss. And then on the second toss, we get a tail. So here we're getting a head and a tail. So that would be option number two. And then we could toss these coins two times. And we could end up getting a tail first on the first toss and then a head. So there's a tail, there's a head. So that would be my third option. And then I can also toss those two coins and I could get two tails. So there is a tail in the first toss, a tail in the second toss, tail, tail. And so that would be my fourth option. So at this point, we've exhausted all the possible options because if I go backwards, if I say, well, I get a tail first and tail first, well, that's the same thing as that. And if I say, I get a heads first and then a head second, that's backwards. So I have exhausted all the possible options. So these are the four total options. So in this particular scenario, the total is always going to be equal to four total possible options. And we call that the set of equally likely outcomes. So we can write that set in brackets. So anytime we write a set of any sort, we always put our set in brackets. So our set of equally likely outcomes for tossing a fair coin two times would be HH, HT, TH, and TT, which stands for heads and heads, heads and tails, tails and heads, or tails and tails. So I have four possible total options. Our first problem says to find the probability of getting two tails. Again, we need to know what that total number of options are, the equally likely outcomes. So again, we had in the previous screen, we had four options. We expressed it as the set of equally likely outcomes. So four is the total. That will be the number in your denominator. Four is the number of total possible options. But now we want to know which options are two tails. Well, is this one two tails? No. Is this one two tails? No. Is this one two tails? No. Is this one two tails? Yes. So I have one out of the four. So I have one option that gives me two tails where I get a tail on both tosses of the coin. And that is the probability of getting two tails. Next, we want to find the probability of getting different outcomes on each toss. So if we look at all of our options, are these two different? Heads and heads? No, those are not different. Heads and tails? Yes, that is different. Tails and heads? That is different. Yes. Is tails and tails different outcomes? No, that is not. So it looks like that we have one, two different outcomes. And again, what was our total number of possible outcomes? Our total was four, right? We figured that out originally, but now we have one, two options where there are different outcomes on each toss. So two out of four, but we can reduce that. Two out of four reduces to one half, and that is our final probability. The probability of getting different outcomes on each toss of the coin when we toss it two times is 1 out of 2. Find the probability of getting a head on the second toss. We haven't been writing this on the two previous problems, but we could. We could write that as the probability of event E, which is a head on the second toss. And if I wanted to, I could write it like this: probability of the head on the second toss. It's just kind of an abbreviated way. Or I could write out this entire phrase and put it in parentheses. So the probability of getting a head on the second toss, and it's going to be equal to this ratio, the part out of the total. And of course, previously we found that our set of total possible options is 4. So our denominator is going to be 4. We just have to determine what the part is. So the part is going to be a head on the second toss. Well, all my second tosses are here, and this is a head, a tail, a head, and a tail. That matches this: head, tail, head, tail. So which one are heads on the second toss? Well, I've got one right here. There's a head on the second toss, and right here is a head on the second toss. So I have one, two options that are going to give me a head on the second toss. So that's going to be 2 out of 4. And again, I can reduce that. So the probability of getting a head on the second toss is going to be a 1 out of 2 probability. Okay, find the probability of getting at least one head. So we can write our probability statement in different ways. It's not set in stone. Probability of at least one head, or we could say the probability that the heads is greater than or equal to 1. That would be saying exactly the same thing, but we are going to set our probability statement equal to a ratio, and we're going to find that ratio by considering the part out of the total. And again, we found that our total number of options is going to be 4, so that is our denominator. And then we just have to determine which of our options has at least one head. So does this one have at least one head? Yes, it does. It actually has two heads. Does this one have at least one head? Yes, it does. And does this one have at least one head? Yes, it also does have one head. Does this final one have one head at least? No, this one is not an option. But we do have one, two, three options that have at least one head, and that is going to be the probability of getting at least one head is equal to 3 out of 4. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.